3 vacuum Raptors, 3 ridiculously long nozzles. 1 engineering truth that turns Starship from a rocket into a space truck. This is the booster bay, and in the next 5 minutes, one continuous take, no cuts, no hype, I'm walking you through the exact physics, the real-world trade-offs, and the payload math that makes those stretched bells non-negotiable. Miss this, and you miss how SpaceX cracked interplanetary flight. Let's dive in. T plus 2 minutes 38 seconds. Super Heavy cuts off. Hot staging fires. Starship's 6 Raptors ignite while still attached. 3 in the center, sea-level Raptors. Short 1.5-meter bells, full gimbal, built to fight atmosphere. 3 on the outer ring, Raptor vacuums. Fixed 4.1-meter bells, built for nothing. Same combustion chamber, same turbopup, same 230 tons of thrust at sea level. So why the drastic difference? Because orbit isn't at sea level. Every rocket engine is a pressure cooker. Methane and oxygen burn at 300 bar, 3600 Kelvin. Gas screams out of the throat at over 3600 meters per second, but it's still dense. The nozzle's only job, expand that gas to convert pressure into velocity. The wider the exit, the lower the exit pressure, the faster the exhaust, the higher your specific impulse. How far you go on 1 tank of fuel. On the ground, you're surrounded by 101 kilopascals of air. That air pushes back. If your nozzle exit pressure drops below atmospheric, the exhaust can't escape cleanly. It collapses inside the bell. Shock diamonds form. Turbulence rips the nozzle apart. Flow separation. Catastrophic. So sea-level Raptors use a 16:1 area ratio. Throat to exit. Exit diameter 1.3 meters. Exit pressure slightly above 1 bar. Matches atmosphere, delivers 330 seconds ISP. Safe, efficient, perfect for launch. Now rise above 100 kilometers. Atmosphere gone. Back pressure 0.0001 kilopascals. No air, no pushback, no flow separation risk. You are free to expand the gas as far as the metal can handle. Raptor vacuum pushes the area ratio to 37.5 to 1. Exit diameter 2.3 meters. The gas expands 2.3 times more than sea level. Exhaust velocity climbs to 4,200 meters per second. Specific impulse 380 seconds. That's a 15% efficiency gain, and in orbit, 15% is everything. 3 RVACs at 380 seconds versus 3 sea level at 330, that's 450 extra seconds of total impulse across the upper stage burn. On a full 1,050-ton propellant load, that translates directly to 1,800 extra kilograms to LEO. Not theory, real delta V. That's another Starlink batch, a lunar landing module, or margin for a crewed mission. The long nozzle is the payload upgrade. But expansion isn't free. Each RVAC nozzle weighs 300 kilograms, 900 kilograms total for 3. That's dead mass the booster has to lift through max Q. So why not make all 6 vacuum? Geometry. Starship's aft skirt is 9 meters wide. 6 4.1-meter bells with gimbal clearance, physically impossible. They'd interfere on tilt. So SpaceX splits the difference. 3 fixed RVACs on the outer ring for maximum ISP, 3 gimbaled sea level in the core for steering. Hybrid architecture, best of both worlds. Re-entry flips the challenge. RVAC nozzles protrude, no heat shield covers the bells. During plasma entry, they see 1800 K peak heating. Solution? Dual-layer defense. Inner wall copper-lined with 400 regenerative cooling channels. Methane flows through, absorbs heat, then burns. Outer layer, ceramic thermal barrier coating, 2 millimeters thick. IFT-4 flew full re-entry profile. Result? 0 measurable erosion. The long bell doesn't just work in vacuum, it survives hell. Raptor 3 sharpens the blade. Same 37.5 to 1 expansion. 80 kilograms lighter per nozzle using carbon-carbon exit cones. Future Starship Block 3 may fly 4 RVACs, enough total impulse for direct Earth-to-Mars injection in a single burn. no tanker, no refueling, just one long nozzle stretch to the red planet. Final check, risk. What if an RVAC ignites too low? It doesn't. Vacuum engines only start above 80 kilometers, full vacuum. Startup transient, handled by sea-level cores. Engine out, upper stage is 2-out capable. The long nozzle adds 0 failure modes, only performance. So here it is, one continuous thread. Sea-level nozzles, short, safe, atmosphere matched. Vacuum nozzles, long, light, expansion optimized. One engine, 2 environments, 1 mission. Turn propellant into orbit. Those 3 long bells aren't a design choice, they're a physics requirement. And they're why Starship doesn't just launch, it stays. This is the booster bay. We don't do sound bites, we do systems. Smash subscribe, ring the bell, because the next long plume is leaving the planet.